And so that took care of my before side. Let's look at the after side. We have m1 v1x over here too. So m1 is 0.17. Its velocity is v1 times the cosine of this angle, 40 degrees. But notice this time we don't know the velocity, so I have to leave v1 unknown. So I'm going to put in v1 times the cosine of 40. And so this is one of the variables that we're going to solve for. Right now it's unknown. That takes care of this term. And then we have to add m2 times v2x. So we'll do m2, which is that 0.16 term. And that's going to be times this velocity times the cosine of 50 degrees. So times v2 cosine of 50 degrees. And so there we have it. Total momentum initially equals total momentum after crash. So we can start multiplying these numbers in our calculator to simplify. So I have 0.17 times 10 times the cosine of 30 degrees. And so that first term becomes 1.472. 1.472. I rounded to 3 places after the decimal. There are many more places I could have kept to preserve accuracy, but I think 3 places, the thousandth place, is actually enough accuracy for a problem like this. This term here is just 0, so plus 0 is equal to 0.17 v1 cosine 40. So I can do 0.17 times the cosine of 40 to simplify. That's going to give me 0.130, so equals 0.130 times v1. So I've left the unknown term in there, and we're going to solve for that later. Over here we have 0.16 cosine 50, so 0.16 times the cosine of 50 equals 0.103, so equals 0.103, and that's going to be times v2. Oops, sorry, that's not equal, that's plus. So that's this term plus that term, right? So total momentum before equals total momentum after. We have 2 unknowns in this equation, so we're not going to be able to solve it. But what we can do, let's start by erasing this plus 0. That doesn't really change anything. We can solve for v1 in terms of v2 and then substitute that into our other equation later.